Hello dears, today's our topic is bonding in coordination compound using valence bond theory means VBT. So first of all we'll discuss about definition of VBT. According to valence bond theory, VBT, bond in coordination compounds is formed when central metal ion hybridizes its vacant orbitals to form hybrid orbitals that overlap with filled orbitals of ligand and form dative covalent bond between metal and ligands. It means that when metal ion, which is a central metal ion in the coordination compound, when attached with different ligands, they form dative covalent bond in such a manner that the ligands donate electron pair to the central metal ion and central metal ion accept that electron pairs and form coordinate covalent bond and form coordination compound after a specific type of hybridization. So first of all, we will discuss about what is hybridization. Hybridization is basically a process in which different types of orbitals having different energies and different shapes are mixed with each other and form same number of orbitals that are called hybrid orbitals which has same shape and same energy. For example, in this phenomena, in coordination compounds, the metal ion, the central metal ion, which is involved in bonding with ligands molecules that contains s, p, and d orbitals. S, p, and d orbitals that are involved in hybridization to form coordination compound, and this hybridization is basically depends upon the coordination number of the compound. Coordination number means how many ligands are attached with central metal ion at a time. For example, if four ligands are attached with the central metal atom, it will form maybe tetrahedral geometry, or it may be square planar geometry. And the hybridization may be sp3 if it is tetrahedral geometry, or dsp2 if it is square planar geometry. Similarly, if five ligands are attached with central metal ion, then shape will be pyramidal. Similarly, if six ligands are attached with the central metal, and that is the most common example in the coordination compounds in which metal central metal ion attached with six ligands, then it will form octahedral geometry. Octahedral geometry compounds are the most common compounds in the coordination compounds in which central metal ion attached with the six ligands molecules. So now we will discuss about what is ligand. Ligand, guys, is basically a special type of molecule or species that can donate electron pair to central atom. It means we can say that ligand is electron pair donor. Ligands may be of two types. It may be anions, which have negative charge, for example, chloride ion, cyanide ion, nitrite ion, acetate ion, etc., etc., which has extra electrons in the form of anions that can donate to the central metal ion. Or it may be a neutral molecule which have at least one lone pair on it. For example, water H2O. In water, oxygen has two lone pairs. Similarly, ammonia NH3, in which ammonia has one lone pair on nitrogen. Similarly, carbonyl C. When metal ion form bonds with ligands, means when metal ion accept electrons from the ligand molecule, they form coordinate covalent bond. That is also known as dative covalent bond. If we will discuss about specially six ligand molecule that have octahedral geometry, two types of complexes are formed. Number one is inner orbital complex, And number 2 is outer orbital complex. Inner orbital complex will form when inner orbitals of the central metal ion are involved in complex formation. Inner orbitals, for example, and metal ion have 3d orbital, then 4s and 4p, then 4d. If 3d orbitals are involved in the complex formation or involved in the bonding with the ligand molecule, then it will form inner orbital complex. Similarly, if outer orbitals means valence orbitals are involved in the complex formation or involved in the donation or acceptance of electron pair between metal and ligand molecule, then it will form outer orbital complex. When molecule form inner orbital complex, when a strong ligand attach with the central metal ion, for example ammonia, NH3, cyanide ion. These are the strong ligands. If strong ligands attach with the central metal ion, then it will form preferably inner orbital complex, in which due to coming of ammonia or cyanide ion means strong ligand towards the central metal ion, the metal ion electrons will pair up and form inner orbital complex. But if a weak ligand comes close to the central metal ion, for example, water or chloride ions or fluoride ions, etc. These ligands, if come closer to the central metal ion, then the molecule form outer orbital complex. Now we will discuss an example using VBT to explain coordination compound bonding. For example, we have an complex cobalt hexaamine. In this complex CONH3 whole 6, and you can see in this complex the central metal ion is basically cobalt ion, CO cobalt. And you know cobalt atomic number is 27. In cobalt atom the atomic number is 27, so the 3D contains 7 electrons. It means it is a 3d7 molecule. So these 7 electrons are placed in cobalt atom in such a manner that 1, 2, 3, 4, 5, 6 and 7 electrons. 2 electrons are present in 4s orbital and 4p orbital is empty. You can see I have arranged these orbitals in the form of energy manner. In these three types of orbital, the 4p has the greatest energy, so it will be written upper side. 3d orbital are on the least side as compared to 4s and 4p orbitals, because 3d has the least energy according to these three types of orbitals. So cobalt atom has 7 electrons in the 3d orbital. It means it is a 3d7 molecule. So cobalt atom, which has 3d7 molecule and 7 electrons in the 3d orbital, when in this complex we can see cobalt atom has CO plus 3 ion. 3 electrons are removed from the cobalt atom. So in this manner, 2 electrons are removed from the 4s orbital and 1 electron is removed from the 3d orbital. So the electrons will arrange in CO plus 3 ion in such a manner that 1, 2, 3, 4, 5 and 6. 1 electron removed from the 3d orbital and 2 electrons removed from the 4s orbital, and that is the configuration of the CO plus 3 ion cobalt ion. Strong ligand ammonia come close to the cobalt ion. The electrons of the cobalt ion present in the 3d orbital will pair up the approach of the strong ligand towards the central metal ion, that is the cobalt ion. So when these electrons are paired up in this manner, they will form, you can see So these 6 electrons pair up in the first 3 orbitals of the 3D. When 6 ammonia ligands approach to these orbitals, one ammonia ligands come close to these orbitals that are empty orbitals. Each ammonia molecule have one lone pair that can be donated to the central metal empty orbital. These 6 orbitals are hybridized, and this one is a d2sp3 orbital, this one is a d2sp3 orbital, and all these 6 orbitals are known as d2sp3 orbitals. So these d2sp3 orbitals are empty orbitals and are hybrid orbitals. When ammonia ligands, 6 ammonia ligands approach to these orbitals, they will donate its electron pair to these empty orbitals. When they give their electron pair to these empty orbitals, and these orbitals are now filled on the approach of ammonia ligand towards itself. And these ammonia, and as we have discussed earlier, the D2sp3 hybridization also shows octahedral geometry, and the complex is inner orbital complex due to approach of the strong ligand in the complex molecule. In this example, we have central metal atom cobalt 3 and 6 ammonia are present around it. All these ligands donates its electrons toward cobalt ion. This will form a complete complex that will form a octahedral geometry.